All right, we are going to look at the second part of section 4.4 for Algebra 2 today. But before we start that, we're going to do a quick review of what you did yesterday. So our topic yesterday was this one. We looked for finding common and binomial factors of quadratics. So let's start with a quick review. Let's say we have 9x cubed plus 15x squared minus 30x. All right, and you can just add this to your notes packet somewhere in the margin. We had two kinds of factoring, and what we're going to look at right now is that idea of looking for something common. We want to pull out the greatest common factor that we can. So we start by looking at all the coefficients, the 9, the 15, and the 30. We need a number that goes into all of those, and in this case, 3 would work. Then we look at our variables. Do all of our terms have an x? So we've got an x cubed here, we've got an x squared, and then we have an x. So yes, they all have an x, which means we could pull an x out as well. And then we look at what is left over after I've pulled that out. So we're basically taking each term and saying, what do we get if we divide out a 3x? So our first term, we take 9 divided by 3, we get 3. We have x cubed, we're dividing out 1x, so we have an x squared left. In our second term, we have 15 divided by 3, which is 5. We had an x squared divided by x, which leaves us with 1x. And then our last term, we have a negative 30 divided by 3, so negative 10. And our x's we took out, so there's none left. And remember, you can always check this by redistributing it back. If you distribute it back in, you would get back to what we had here. Okay? Then the second type of factoring was the idea of taking some kind of trinomial. Let's say we have 6x squared minus 11x minus 10. And I said to factor that. So our first step is to look at our options for our 6x squared. We have a couple. We could do a 6x times 1x, or we could do a 3x times a 2x. In both cases, we would end up with that 6x squared. And right now, I don't know which option I'm going to need. Then we look at our negative 10, and we say, how can we multiply to get a negative 10? Well, again, we have a few options. We could do negative 1 times 10. We could do 1 times negative 10. We could use 2 and negative 5, or negative 2 and positive 5. Again, I don't know yet which of those options I need. But I do know that when I do my foiling, my insides and outsides have to combine to be negative 11. Okay? So looking at our combinations, we probably don't want to multiply, let's say, the 6x by a 10. That's going to give us a 60, which is going to be way too big. So let's start with our smaller numbers. Let's try our 3x and our 2x. If it doesn't work, we can always go back and try the 6x and the 1x. And then again, because I'm looking for smaller numbers in the middle, nothing huge, I'm going to start by using the 2 and 5 pairs. One of them has to be negative, but again, I don't know which one yet, so it's really a trial and error. So let's say we try putting a 5 here and a 2 here. When we look at insides and outsides, inside would give us 10x, and outside would give us 6x. And one of those will be negative, but either way, it's going to add up either to a negative 4 or a positive 4x, not the negative 11 that I'm looking for in the middle. So let's switch those around. Let's say we try putting our 5 on this end and our 2 on this end. Now when we look at outsides and insides, our inside gives us 4x and our outside gives us 15x. And remember, we wanted one of them to be negative to get our negative 11 in the middle. So if we look at this, we need a negative 11. If we made our 15x negative, then that would add up. Negative 15x plus 4 would give us negative 11x. So we need this outside piece to be negative and our inside piece to be positive. And again, you can FOIL that out and double check that it does work. All right, so now today we are moving on to the second learning objective, which is to factor some of our special cases. So we're going to start out just listing all of our perfect squares because some of our special cases involve perfect squares and we need to recognize what those numbers are. So take a few minutes and let's fill in our chart here. Basically, we're just taking each of the numbers in the top row and we are squaring them. So if x is 1, 1 squared is still 1. If x is 2, 2 squared would give us 4. 3 squared is 9. 4 squared is 16. Go ahead and complete the chart. Just pause the video and turn it back on when you're ready. All right, let's check our work. 5 squared is 25, 6 would give us 36, 49, 64, 81, and 100. Those you should be pretty familiar with. 11 squared is 121, 12 squared is 144, 13 is 169, 14 is 196, 15 is 225, 16 is 256, 17 squared is 289, 18 squared is 324, 19 squared is 361, and 20 squared is 400. Again, you probably don't have those memorized, the larger numbers, but we do want to make sure that we recognize those perfect squares when we see them in our expressions. All right, so factoring a perfect square trinomial. It says, what is 4x squared minus 20x plus 25? Now, the first thing I look at is this a perfect square? Is 4 a perfect square? Yes. If we have an x squared, that's just x being squared. So, yes, our first term is a perfect square. Then I look at the 25. Is that a perfect square? And yes, it's on my list of perfect squares. So I have a good chance that this is what we call a perfect square trinomial. But I do have to check the middle. The middle has to be very specific. What we do is we take the roots of the first and the last terms. So we said that 4x squared is really just 2x being squared. And 25 is just 5 being squared. So we take those pieces, 2x times 5 gives us 10x, and we double that, and that gets us a 20x. And so that is our middle number here, which means it does fit that pattern. Double the product of our two pieces. Now we can account for that negative or adjust for it simply by thinking of this as a negative 5. Because negative 5 squared is still 25, but now when I do the product, I would get the negative here. So what we're looking at is what's called a perfect square trinomial. And the reason it's one of our special cases is that it factors into two identical factors. So let's pretend we didn't know it was a perfect square trinomial. If I had just asked you yesterday to factor this, you would have looked at the 4x squared and said, well, that could be 4x times 1x or 2x times 2x. Looking at 25, we could have 1 and 25 or 5 and 5. Or we could have our two negative combinations. That also gets us the positive 25. And then I would look at how I can pair those up. So let's say we start checking our 2x combination and we check our 5s. Okay? We know we need the last term to be positive here, but the middle term to be negative. So we're going to try two negatives. And then if I check, foiling it out, 2x times 2x gets me my 4x squared. Last, negative 5 times negative 5 gets me my 25. And when I check insides and outsides, I get negative 10x and another negative 10x. And that accounts for my negative 20x. And so we call these perfect square trinomials because both of these factors, this one and this one, are identical. So we can write this in a shortened way by simply saying that is 2x minus 5 quantity squared. Okay? So let's look for a few more of those examples. Remember, the first and last pieces in our trinomial, the first and last terms, have to be perfect squares to even check for a perfect square trinomial. So is 64 a perfect square? Yes. 64 would be 8 squared. X squared is just x squared. So let's think about splitting this up into 8x and 8x. Is 1 a perfect square? Yes, it's 1 times 1. Now, remember, we can also do -1 times -1. And since our last term is positive, but our middle is negative, that tells me I need my two negative signs. So we know we've gotten the 64x squared, the f part of FOIL, and we know we have the 1, the L part of FOIL. We just have to check outsides and insides. And for both of these, we get a -8x, which gets us our -16x in the middle. So we would simplify this by simply writing 8x minus 1, quantity squared. We have two of those. All right. The second pattern that we're looking at is what we call a difference of two squares. This is another one of our special patterns. And this time we have a perfect square minus another perfect square. It has to be the difference, meaning subtraction, the difference of two squares. And this one is special because it factors into two almost identical factors, except one has a positive and one negative. So looking at our next example, we have 25x squared minus 49. This is a perfect square, and this is a perfect square, and we have a difference. So it is the difference of two squares, which means it should factor into two binomials where one is a plus and one has a minus. And then we simply look for their roots. So 25x squared would be 5x times 5x, and 49 would be 7 times 7. And since we have a positive 7 times a negative 7, we do get our -49. All right, our next one. Again, 16x squared and 81 are both perfect, so we look for those roots. The square root of 16x squared would be 4x, and the square root of 81 would be 9. And we need one positive and one negative to make a -81. And then what happens inside, if we check that, we get a positive 36x and we get a negative 36x. That's why we had no middle number in here. Okay, it was not a trinomial, it's simply a binomial. Okay, so those are the two patterns that we're looking at today. All right, our special cases. We have the difference of squares and we have the perfect square trinomials. So make sure you know how to factor those two types. Our assignment, we are on day 2, so we are looking at this one here. Okay, so you're going to do 50 to 58, 60, 61 to 73 odd, 98 to 100, and 103 to 104. And then on Monday, we will look at a worksheet reviewing all of our different types of factoring.